Okay, everybody, thanks for coming out to the October 2016 meetup for Austin Golang, or just Go, as we should call it when we're not Googling it. I am Trevor. I'm one of the co-organizers, along with Ian and Cody back there managing the DJ booth, or whatever we call this AV rig. Yeah, he's going to wait for the drop, everybody. Today we have Illya Busigin, who is going to be here to talk to us about Goa, which is a very exciting, very user-friendly tool for rapidly developing design-driven APIs. So he has a t-shirt. Unfortunately, we don't have t-shirts for all of you, but we did get in touch with Raphael Simon, the Goa maintainer, and he provided us with that most desired of all developer currencies, a die-cut sticker. So make sure you get your die-cut stickers here at the end, and Illya, take it away.
Thank you. Can we switch over to the screen share? Oh, okay. Thank you. This looks a little, I'm not seeing it on my screen, unfortunately. In fact, sorry for the technical difficulties here. I'm going to just mirror. That will work. Okay. Let me get started. This presentation is going to be about Goa, which is a DSL for creating, APIs and much more. We'll talk about that today. A little bit about myself. I'm the VP of Engineering at Engaged. Engaged is a software company downtown, which is building a platform for HR communication, which has a mobile web and mobile web portals, and we also have a health platform to help people get healthier. It's kind of like wellness, but incentivized. Background is in about 15 years of software development. I started in VB doing Excel work and kind of worked my way up to mobile development when the original iPhone came out. And about 2 or 3 years ago, I switched over or kind of dabbled in back-end mobile development and started with Node.js, which is very interesting. Lots of really cool technologies there. But there are definite limitations. And about a year ago, when we kickstarted Engaged, building our platform, switched over to Go and haven't looked back. So that's a quick bio about me. What is Goa? Goa is essentially a DSL for creating APIs. The value proposition of today we're going to talk about a little bit more about what Go is, how it looks, how it works, the value proposition, why you should be using Go is when designing your APIs. And then we'll do a little bit of live coding where we'll actually build the Goa API. And I'm sorry I cheated here a little bit. We've actually kind of pre-built it and using the Goa seller example. But we'll kind of tweak that, regenerate that, play with that, and then also deploy that to the cloud. In addition to Goa, another thing we'll talk about today is a tool called Convox. Convox is essentially a Heroku tool which allows you to deploy to Amazon Web Services using Docker and deploying to Elastic Container Services. Before we get into, here we go. So what is Goa? Goa is a holistic approach for building APIs. What Goa gives you is code generation. It is design-based, and you have very powerful context. Let's talk about what that is. So in traditional API development, you leverage a framework to build an API. Traditional frameworks, I would say there's GoKit, the standard HTTP framework, and a whole other set of libraries out there. Go is a little bit different in that you will define your API via a DSL, a Goa-specific DSL, and then from that DSL you will essentially generate your API and all validations that come thereof. The benefit of that, which we'll talk about in more detail, is that you essentially have a single source of truth for your API, and that single source of truth can bubble not only down to the API implementation, it can bubble down to the API documentation, a Swagger file, Markdown, and into JavaScript libraries as well as Go client libraries and CLIs. Another key feature of Goa, which is very, very useful, is the concept of context. Everything in Goa, since you are defining your API, your inputs and your outputs, it has a context associated with it. So when you have a request come in, you have a request context. Let's say it's a show user. And that request context is strongly typed so that if that user has a user ID, if there's any other parameters associated with that request, you can essentially fetch it from the context. The value prop in that is if you change something in your design and you're referencing that request context, that will essentially result in a compile error after you regenerate your code. It forces you to be very strict about how you're accessing your request context. Same thing with the response context, in that you can also do the exact same thing. The response context is strongly typed. So if I'm passing back a list of users, and let's say it's using the default view, I have to pass that back. I can't use a tiny user view or some other view like that. And we'll talk more about that. Here on the screen, what you're seeing is a little bit of a preview of what Goa, the DSL, looks like. One of the things you'll notice, and you may wrinkle your nose at first, is the dot imports. Dot imports are typically frowned on in Go, but when using the DSL, it makes the code much more readable. So I think we can probably forgive Goa in this transgression. It's not really a transgression, I think, when it comes to DSLs. Before we talk a bit more about Goa, what makes a great API? There are really two audiences for this. Well thought out interfaces, super, super important. Great documentation examples are also very important. Security, much more important, I think, nowadays, and given a lot more weight than it has in the past. Whether that's SSL, using common authentication techniques like OAuth, JSON Web Token. I think these are very important for a good API instead of a bespoke authorization method. And then, of course, well-tested and highly responsive. These are things a user wants from an API, and as API designers, we want that as well. From a creator standpoint, number one, we want an API to be well-structured, easy to maintain, and extend. Goa is a tool that kind of allows us to do that. As a developer, an engineer, artist, craftsman, one of the things I think we constantly need to be doing is looking at tools that help make us be a multiplier. Goa is definitely one of those tools. So, value proposition of Goa. Best code is no code at all. That's on a coding horror blog. There'll be a link in the presentation, but this is something that kind of resonates with any developer who has had to maintain a large code base. The code that you can delete, the code that you don't have to write, is fantastic. And Goa kind of is right up there with that, because instead of writing code for your validation, instead of writing HTTP handlers, you're writing the DSL, which will generate all that for you. And that goes kind of hand in hand with the design first philosophies. You have to really think about how your API is structured, how you want to set up all your resources, your media types, your user types. Because it's that DSL and it's going to generate that code, you have to put that thought up front. Now, does that mean you're going to have a great API just because you're using the DSL? Absolutely not. You can still write terrible APIs with Goa, but it does give you an additional step to doing that, and hopefully you'll take that step and write a good API. Single source of truth for your API. So in many companies that I've been at the past, the API documentation will say one thing, and the implementation will be another, and then the developer who wrote that code will say it does something else. Goa, or leveraging Goa the right way, actually kind of eliminates all this. Since the DSL is a source of truth, the DSL can generate a Swagger file. That Swagger file can be hosted, with the Swagger UI. That Swagger UI can be used to not only document the API, show good examples, it can also be used to test the API. Assuming you keep your Swagger file in line with your deployments, there's no question of, hey, what does my API do? How does it behave? What are my inputs and what are my outputs? You get essentially all that for free. In traditional, API development, you may have tools to extract documentation from your code. JavaScript definitely has a lot of those, but those tools are usually not that great. And being able to not only extract the documentation, description of your resources and endpoints, but actually examples from that same DSL makes it incredibly powerful. So in my mind, the single source of truth is probably the biggest selling point. And once you understand it, embrace it, and incorporate that and kind of into your process, you're going to save yourself a whole lot of time in API development. Another thing which is quite interesting with Goa code is that it generates very idiomatic Go code. If you actually look at the generated code, and we'll look at that later on in this evening, you'll see that the code it generates is not just some random code that may or may not be performant. It's code that you may have written at one point, or will write code just like that in the future. Now, does that go to say that all the code is generated code is great? No, some of it's a little bit ugly. There is duplication, but at the end of the day, the code gets the job done. generating documentation file like we talked about. The Swagger file you get is invaluable for communicating to external teams, whether that's front-end developers, mobile developers. To get that Swagger file is literally just one command from Goa from your DSL. You also get a Go package library, which you can integrate with other Go libraries. You get a CLI client, you get a JavaScript client, and then there's a generator which you can hook into to generate really anything that you want to generate. The generator component of Goa is really what I think puts it over the top, because the use cases the DSL thinks of are X, and the use cases that you may have are definitely going to be more than X in the evolution of your product and your API. And with that generator, you can essentially bolt on either an existing DSL, hook into the generated code to generate stuff that's kind of supplemental to your API. It's a very powerful construct. One of the things we use the generator for at Engaged is permissions on our role-based access control endpoints. Rather than having a manual table to maintain all of our permissions, we hook into the generated models to essentially generate all our permissions, which get automatically inserted and updated into the database. And this is very helpful, removes a manual step from having to manage permissions and roles. So API design lifecycle with Goa. I'm going to talk about it first, then we're going to dive into some code. When you're creating a service with Goa, it starts with design. And the Goa DSL lets you describe basically your global properties for your API. In fact, this slide is not accurate. So this is actually showing a resource. Let's go ahead and look at what an API definition looks like. Is that big enough? Fantastic. So this is what the base API definition in a Goa project looks like. You have the name of the API, a title and a description if you so desire, any kind of contact information, a license, and then a documentation link. That documentation link, in an ideal world, links directly to your Swagger file. You also have a base path for this API. In the case of versioned APIs, depending on how you do your versioning, you may have a V1, you may have a V2, it might be a date. This allows you to kind of set that base path, which all your resources and endpoints will inherit from. Another very powerful thing with Goa is the ability to handle cores. And this is what this origin definition here is doing, basically saying, I will allow cores requests for this endpoint. Now that in and of itself is useful, but not that useful, because in development environment that URL can be many different things. Goa recently introduced a feature where this cores request can actually be a regex, and that can be very useful. So instead of having n number of cores definitions, you can specify one with the appropriate regex, and then you're off to the races. In addition to that, you can also define your response templates. The typical response template you're going to define, and we have here in this basic example, is just a created template, response template, where whenever I return back a created response, I can specify the status code, I can specify any headers that matter to me, or anything else that I could potentially stuff in the response. So in this API, when we create a resource, what we're going to get back is a 201, assuming we use the created response template, and it's going to return a header with the location which has the href to the actual resource itself. Let's go back here. So API design lifecycle on the project structure. So when you generate Goa code, what you're going to see is a set of folders, depending on what you generate with, that will also get generated in the root level of your project. The folders, from top to bottom, we have an app folder. This is really the primary Goa generated package. In that app folder, we essentially have a test folder, which has tests for said app. We have our contexts, which are both our request and response contexts. We also have the controllers. And one of the very interesting thing about Goas, which makes it very useful and easy to extend, is that the controllers are a interface. They're not a concrete implementation. So how you use Goa is you essentially generate your app. You generate your app package, and then you are going to generate you're going to essentially write a struct or implementation that adheres to, in this case, the account controller interface. And then you'll essentially mount that on the Goa service. So this is very useful because, number one, you control what that business logic package looks like. You may need a database reference. You may need a reference to a caching layer. the sky's the limit. Since you have control over that, you can do whatever you want. Another useful thing is since it's an interface, when you're doing testing, you can mock it out. And testing, for us is very important, and being able to mock things out makes that all that much easier. We also have, in this case, an href file for all of our media types. They can potentially they have an href to a location, and this file would essentially contain the href builders, for lack of a better term. Media types in Goa are essentially the types that get returned from a request. In this case, the media types file will have all those media types. You'll notice that on a media type, it also has some validate functions. You can call these with your service if you're modifying that media type before returning it, rather than trying to return an erroneous media type. Yes, absolutely. I think that's a brilliant idea. So let's look at media types. So here's the account media type. In fact, let me go groups, view columns. Let me shrink this down a little here. Let me know if this is still visible for y'all. Fantastic. So this is, in Goa, the primary package, or where you're going to start, is the design package. The design package is where you define your media types, your user types, your resources, and your overall API definition. In this case, what we're looking at is the definition for an account media type. You can see on here we have a description, we have various attributes. On those attributes, we also have an example, this which gets bubbled up to our Swagger file. We can also have validations on here to, let's say, limit this, in this case, the ID column to a certain value. We won't do that, but we can have validations which are built into Go. There are min-max validations, and there's also regex-based validation, which can be very useful for certain types of fields. We have an href, which is returned as part of the object, which is also on our right-hand side. And then a few more fields, name, created by, created at, and our required fields here at the bottom. One interesting thing with Goa and with APIs in general is depending on where that media type is going to be returned, you want to have different views. If you're returning in a list or it's a child of another media type, you may only want to have a tiny or a link view. And Goa allows you to essentially define all your different views for your media type. One of the things you'll have to have by default for all your media types is a default media type. And if you don't specify a default and you try to run goagen generate, it will essentially yell at you and say, hey, you need to have a default media type. Nothing in Goa is implicit. Everything is explicit, which is, if you're not a fan of implicit behavior and magic underneath the scenes, is fantastic. So explicit wins over implicit, especially when it comes to DSL and API generation. Another thing we get here for free is the validate function. And depending on what validations I put on each of my attributes, those would essentially, this validate function would reflect those whatever those validations were. So we've looked at media types. Let's go ahead and look at our user types. And so in our user types, and just a high-level overview of what this API is, this is essentially an API for wine bottles. In our user types, we essentially have in our responses, we essentially have accounts, and then we have bottles. We actually can create accounts, but the primary thing that we're going to create is going to be a bottle. For that, we essentially have a bottle payload. You can see that instead of specifying a media type, this is just a type. On that type here, you can see we actually do have some validation. In this example, we want this to be at least 2 characters long, and then we have an example here. Let's go ahead and pull up the associated user type files. So that is the internal bottle payload. Let's pull that up here. So let's look at a more interesting example here. So color, for example, has an enum. It's an enum string value, which can be red, white, so on and so forth. You can see that on the right-hand side in the validate function, Because we've declared that as an enum, it will essentially validate to ensure that the value in color is always going to be one of those values. This can be incredibly useful. Again, going back to, instead of you having to worry about validation at the business logic layer, if your validation is at the user type or the media type layer, before it even hits your business logic layer, the validation will be applied. So if this is not red or it's some other value for the color, it won't even hit your business logic layer. And so what that means is that there are certain guarantees that come with Goa when the code actually reaches your business logic. So with those guarantees, that means you have to do less validation on your side. Your business logic is then focusing on just business logic, and that is one of the big value propositions of Goa. So API definition, we looked at this. This doesn't translate directly to any specific model object or file specifically, but let's see if I can find the closest translation for your APIs. When we specified our cores, we have some cores handlers on each of our controllers. Cores, cross-origin resource sharing, which apply when you're talking to an API directly and not through a browser. Cores really doesn't matter. But when you're on a website and that website is making an API call to a backend API, I believe it's the browser. The browser is going to make the cores request to your API to see, hey, can I talk to you? And if the cores response can be yay or nay, it's like a 200 response with some headers, acceptable headers, or I believe it's a 400 or a bad request. And if it's a bad request, basically the browser will prevent you from talking to the API. And the use case for cores is to prevent a site from being malicious. One of the use cases is prevent the site from maliciously reaching out to APIs and maybe communicating information from your browser to said API.
So it's a way that, sorry. Yeah, so cores is kind of a way to allow certain scripts from other origins to be sort of okay within the browser for sort of communicating with two different origins, right? So what's happening there is there's an HTTP options request that's going to it, and it's basically saying like, what am I allowed to do? It's kind of what you see. I'm not giving a real great. It does. It uses an options call for a JSON API. It really doesn't matter at all because basically it is there to prevent malicious scripts that happen to have been loaded on a page through a cross-site scripting attack from being able to like grab crap and send it off somewhere else.
Alrighty. So one of the values, the huge value props of Goa is this concept of a context. All familiar, well, hopefully we're all familiar with the context property in Go. To provide a little bit of refresher, context is kind of like a bag or a bucket where you can stuff pretty much whatever you want in there. Context has been overused in a lot of Go libraries I've seen, but how Goa uses context, where it's embedding it in its own struct, actually makes a lot of sense. So I believe the recommended practice of using context is to put data in there which is, I would say, transient or associated with the request. You don't want to use it as a bag just for whatever you want to put in there. It should be associated. In this case, it's associated with the request. So on here we have this create account context. You can see we have an embedded context. We have a response data object, a request data object, and more importantly, we have a payload. This payload is essentially equivalent to the, let's see here, the create account payload. And this is, what's that? I'm in bottle. Yeah, this is the user types.go. I should have. Create account payload. Okay. Oh, it's here in the context.go. Okay. I guess I'm not sure how that makes sense, but I'll take it. So the create account payload, you can see the minimum we need to actually create an account for this API is a name field. So rather than you having to reach into the request and reach into the JSON and pull out the parameters for that, because you specified that for this create account, I need this payload, and that payload has to have at least this name that it basically embeds all that in the request. And how that actually looks like in the controller, let's go ahead and take a look at account. And I'll move that over here. I'm going to move that back to context. Oops. Oh. So when we're creating an account here, this is in our handler or our controller. Essentially what's getting passed in here is that create account context, which has the payload on it. Here we're essentially creating a new account in our MockDB. We're extracting the payload, and from that payload we're essentially assigning it to our payload.name object. There's also some other save and other logic in here, but the core thing, the key takeaway from this is your business logic, and what you implement here is up to you. And the parameters that you care about on the request are going to be in that context object. You're good. All right, let me pull that up here. That would be very helpful. So let's going with the create resource. We have here a resources definition. In this case, this resource is all about account. Account has many different endpoints. We have a list, we have a show, we have a create, update, and delete. Each of these is a unique endpoint. At the top of the resource file, or resource declaration, you essentially have a default media type you can associate with it, with the resource. And if you don't specify a media type, it will essentially leverage this default media type, and then also a base path. This base path inherits from whatever path you specified in your API.go or your API definition. So in this case, I believe that the base path is seller. So I'm just going to type it out here. So this actual request would actually be seller/accounts. But because we essentially have that kind of inheritance from the resource path, we don't have to spell it out here. On each of these, we essentially have an action, which is an endpoint. In this case, list is you're just going to call /accounts, and that will essentially, with a get, and that will retrieve all the accounts. The response we're declaring here is a 200 response, and we're turning a collection of accounts. This can be whatever we want it to be. In a typical kind of CRUD RESTful app, this is kind of what this is. This DSL is describing that. In addition to just being able to make a get, if I want to parameterize the request, so in the case of show here, I can actually specify a parameter in the URL or the request. And in this case, I want to specify account ID for show. So in this case, it would be accounts/account ID, whatever that might be. It could be 1, 2, 3. In the parameters section here, I can then specify that account ID is an integer. I can add a description, and then I can also add validation here as well. In this response account, since this is essentially a get a specific resource object, we have a 200 OK response. We have a not found. We also have a bad request. We can put more, but those seem to kind of cover our bases. In the response here, we can also specify an error media object. Error media is just a way of saying, it's a bad request, and when the response that you get will actually return this error media. So create, which is what we're looking here on the right-hand side. As we saw before, this is a post. We have a description on that. There's none of that description bubbles down here, but it will bubble up into the Swagger. And then we have a payload. In this case, rather than referencing a payload that we've already created in the user types, we've actually defined an inline payload here, which is just the payload has to have a member of name, and that name field is required. If we actually wanted to use this payload in other places, rather than defining it inline, we could specify in the user types, kind of like how we specified bottle payload. But since this payload is so small, it only contains the name, there's really no need to declare in other areas within the DSL. Update and delete also kind of follow that same pattern. Update has an account ID and a parameter. Delete is the same exact way. From a practice standpoint, when designing Goa APIs, you'll notice that the seller sample project is kind of set up where you have the API definition in the design folder. You have a health.go. You have media types, models, and resources, and user types. we've built probably 8 or 9 different Goa APIs, and we've kind of strayed from this, and rather than breaking things down by their different associated type, we'll have in our design file like an account.go, which will have the user payload at the top, the media type, and then the resources all defined within that file. So rather than having to hop around and see what is associated with different aspects of that account, everything's in one file, and that has actually worked out very well for us. So we have resources, we have user types. Bottle payload, as you can see, is a lot more complicated than other payloads. But because Goa has the ability to specify all this validation, which you normally would have to do in your business logic, is handled by Goa. So we've designed this wonderful API. We've put together this DSL. How do we actually generate it? Yes? Great question. So in this case of a bottle payload, where this is actually used, and let's take a look at that in the resources section, that actually gets used in the create action. So in this case, this is the bottle resource. We have an action which we're calling create. That action is a post action, add a description on here. The payload, instead of specifying an inline payload like we did in our previous account, we're actually referencing that bottle payload. And then on that bottle payload, we can essentially say, because this is a create, you need to pass at least these fields to associate with that payload. Bingo. Yes, yeah. When you call this API, you're going to pass a JSON object with those fields. And we'll actually, as part of this, we'll exercise the API locally and remotely when we deploy to the cloud. Mm-hmm. So, mm-hmm. Yeah. So looking at that actual bottle.go implementation, which references this essentially create, you can see here that we have an app.create bottle context. On that app.create bottle context, if I look at that context, I can see we have a payload, and that payload is the create bottle payload. So instead of you having to extract it manually, you have it for you right within the context itself. So without further ado, before we jump into generating the API and hitting it and looking at a few other things, are there any questions about Goa, media types, resources, actions, or anything else that you feel is relevant to cover? Yep. So in this example, great. So the question was, in the design folder, we have a lot of different files, kind of documenting media types, user types, resources. The question was how we do it engaged. How we would do it in the context of this API, there are essentially 2 main media types. There's an account, and then there is a bottle payload. Instead of having models, resources, user types, media types, the way I would do this is I would have an account.go, which has my bottle, my account payload, my account media type, and my account resources, right, resource and actions, and then I would have a bottle.go kind of mirroring that same approach. So that way you have everything kind of that is relevant to that resource in one file. That is a great question. So Goa Design DSL can absolutely be shared between different DSL. So in the context of where you have multiple Goa services, you can essentially have maybe like a design sub-package called, let's say, shared, right? And then in that shared, you declare all the shared model types or media types that you want to expose to other services. And they can either consume it one of 2 ways. They can consume it, actually, the way they want to consume it is probably within their own DSL. So that way you have a canonical definition for your models or your media types or whatever you want to share, and then you edit it there and it propagates to whatever child APIs or APIs that will use that package. What's that? That's exactly how we use it. We have a shared, we have a design/shared, and then we leverage that in other areas within the app. We actually have if for any kind of shared resources within our API, we'll actually have a shared folder, kind of a higher level hierarchy, so it won't necessarily be under that specific API. So for generating Goa code, let's take a look at how that's done. Let me So before we actually generate some code, there are essentially many different things you can generate with Goa. The main one, the one that you care most about, and the one that everything else needs, is the app. So you can see here that we have a makefile with a generate command, which will kind of iterate through all our different possible generate commands. In this case, we have the app file, which can get generated. We have a Swagger, so Goa gen Swagger will generate your Swagger. That will essentially generate it in a Swagger folder. So we look back here to our project structure. We have design, models, tools, a couple other. And then we also should have a Swagger. I'm not seeing it, but we'll generate it. We'll see if it shows up. The schema, I don't rightly recall what schema generates. Trevor, any idea what schema, GoaGen schema does? Okay, I haven't used it. I'm sure it does something important, but we'll look that one up. Client will generate the Go client, which you can interact with and import into your other Go projects. JS will generate a JavaScript client, which you can leverage on your front end. And this last command here is what generates the model files from Gorma. So let's talk a bit about Goa and extending Goa. One of the ways you can extend Goa is by hooking into its code generator. And to do that, you can do that in a couple different ways. You can write your own DSL, which then can hook into the Goa generator generate command. Alternatively, you can just hook into the generated structures and then leverage those generated structures to pull off metadata or do whatever you want. And that's kind of how we use that at Engaged, where we'll walk through the generated structures and essentially extract each endpoint and create a permission for that endpoint. Gorma is doing a lot more in that it's essentially trying to generate your ORM layer, ORM access layer for your data. And this is essentially, if you're going to have a DSL or some other package that hooks into Goa, that's how you would do it. So we're essentially referencing the design folder within our Goa project. The typical convention is that within your package, you're going to have a design package. And that's, you may have multiple design packages, but if you have multiple, you probably want to separate it out. Then you're going to call a gen command to point to the package, which will then generate whatever it will generate. In this case, we're pointing to the Gorma package to generate our models layer. The models layer, which we haven't looked at yet, is essentially the ORM layer for GORM. GORM is a Go object relational mapping tool. Some people love it, some people hate it. I am ambivalent. If it gets the job done and doesn't get in the way, I think it works great. I think there are better tools out there, but that's a conversation for another day. In the models and how Goa works, Gorma works, is in the design file, design package, we actually have a models.go. This models.go has its own DSL, and through this DSL, you essentially specify how a model, let's say account, what actual media type it renders to, what fields are important on it, what relationships. In this case, an account has many bottles. Bottle is the same way. What does bottle build from? Because bottle essentially can build from a create or update. How do those relate into my ORM layer? Gorma is fantastic for simple data models. If you have no relationships, if you have simple one-to-many relationships, you will probably be okay with Gorma. But as soon as you start getting into the land of many-to-many or strange relationships or join tables, Gorma starts to get a little twitchy. And we actually have some pretty complex data models that engage, and how we've handled this to still leverage the benefit of Gorma is to generate the model code and in a separate package, and then kind of pull it over piecemeal run our tests against it, make sure everything's still working.
Yeah, I would say that, I mean, Gorm is actually a pretty decent ORM if you don't have like reflective hatred of RMs and you want to spend 6 weeks writing boilerplate SQL for your new app. Um, Gorma, I used it a little bit and I found myself, not kidding you, made 3 PRs in the first day and a half, and using it for very basic bugs. Brian Kettleson has admitted he was very overloaded and was looking for someone to take over this plugin. Again, like Gorma is a plugin to leverage the Gorm ORM inside of the we're talking like pretty major misses there. I mean, there's a hell of a lot of bugs, and I think it's great that you can start off with it, but then I would definitely recommend, like, I got to a point where I actually took it out of my make file for the GoAgen statement for it, and I was like, I'm okay with what it's already done. I'm leaving it alone, and I will continue to extend it.
That's exactly what we did because it just kind of starts to break down when things get more complicated.
It does. It makes some like useful constructs for you, but after that, it's just, you know, it was a nice little bootstrapper thing. It's kind of, it's whatever a notch past point concept is, or a proof of concept.
Yep.
But also too, doesn't it
You can always access the, yeah.
So you could use, yeah, Gorm, again, Gorm, completely separate thing. It's, you know, kind of a portmanteau of Go ORM, right? Completely separate thing, maintained by a Chinese fellow named Jinzu on GitHub. Very, very useful ORM in my opinion. If you're doing a couple projects, you can drop straight to SQL. You can do a lot of different stuff with it. And this is just a way to kind of DSLify like that. So, you know, you can create this stuff and then just go nuts using Gorm in your other code, right? Just using it directly as an ORM is fine. But the sort of tie-in to Go here, unfortunately, I think is really ready for much beyond kind of
Yeah. Question?
that brings up my life cycle question. I'm wondering about, can you show the handlers? Like, okay, so we've got the API defined.
Mm-hmm.
And use we'll generate that code.
Okay.
Eventually you're going to go somewhere that writes the code that actually does the handling of those Java
Sure.
calls. What's the life cycle for like when they change code that stuff regenerates?
controllers are just made as
Yeah.
files and from there you can do
Yeah. You own all the controller code. Once you do the initial Goa gen bootstrap, which is the first thing you'll do to generate everything, which is inclusive of the controller stubs, it will never touch those files again. So it's up to you to kind of maintain that, make sure everything is still working.
We'll create an example function for every resource, like inside your resources for every resource action defined. So if you just have like a create function or whatever that you use, and then make create but after it generates them, it never touches them.
So like on the iteration runs, then like that handler teaches you that will regenerate. Won't touch, I know like the change bar won't touch that code. I wouldn't touch it.
Yeah,
It'll change the context in the previous line.
that's yeah, it won't touch anything else. So like if you, let's say you had 4 resource endpoints, you generated your stubs, you're going to have your 4 stubs, and then you add a couple more, it's not going to add the additional 2 for you because
Like if you change the things that you could, for instance, like create account context, if you change like the parameters in the user type that can be passed in there, then that it will regenerate up in the top of the app directory. It will regenerate the context.go. So the thing getting passed into your handler will not suddenly have more memory than the struct because it will have
Yep.
So it doesn't regenerate the controller file, but it regenerates the things that get passed into the controller handler, and therefore it leverages stuff out.
Yeah. If you rename your, I guess your endpoints, those context variables change, then of course it'll break and you'll have to update it. But anything that's kind of additive, you know, let's say from a parameter standpoint, you can just access it from the context itself. The controller stubs only get created with Bootstrap. That is correct. Yeah, so this is like, it's just they're handlers, controllers. Some people get upset over the naming. You can put them wherever you want. In this example, they put them in the controllers, and that's kind of what we do as well. Yes, the controllers were manually moved. Cool. Yep. So. So that brings up a great point. We haven't looked at main yet. You've created all this, you've generated your stubs, you've implemented the business logic in your stub. What do you do with that? And this is the stub main function for the seller example. What you're going to see here is we're essentially creating a new Goa service by calling goa.new. There's some loggers which we're injecting into the service as well. Goa has the concept of middleware, which is basically just like any HTTP middleware you would expect. Out of the box, Goa comes with a whole bunch of middleware that you can use. Request ID, log request, error handler, recover. Recover will, if your code panics, it will prevent it from blowing up the program and essentially bubble that back up to the response if you so desire. The other middleware, which we haven't touched on, and we'll touch on it briefly, is concept of security. So Goa has built in some different security protocols. Goa supports basic auth, it supports OAuth, and it supports JSON Web Tokens out of the box. Now, when I say out of the box, it's not exactly out of the box, because if you're doing anything with JSON Web Tokens, you essentially have to sign those tokens, so there's still a bunch of business logic you'll have to implement. But once you implement that business logic and then you register your middleware, everything will just work. From a security standpoint, and we're going to hop right back to the resources just for a quick second, we can actually secure any of these endpoints by using the security DSL. When you're defining security, you specify the name of said security. So like if we had JSON Web Token security here, and I wanted to protect this endpoint, I would essentially just call into the security DSL and then specify whatever security name I had. This API, yeah. Yep. Yep. So yeah. So yep. So Goa, from a functionality standpoint, is great. The documentation, both from the examples, is also fantastic. The Goa design GitHub repo organization, if you go there, you have examples for Goa seller, which is kind of what we're looking at right now. We have Gorma, we have Swagger services, Gorma seller, which leverages the Gorma integration. If you're interested in Goa, I highly recommend kind of going through the Goa design GitHub organization. And like Chris mentioned explicitly, the examples are a great kind of location to find examples of the various different ways you can use and leverage Goa. Goa, in addition to kind of supporting standard HTTP, it also in theory can support WebSockets, gRPC. Goa has this concept of encoders and decoders. Not going to touch on it a whole lot other than mention it, but in theory you can kind of support all those different protocols with Goa. Raphael, the gentleman who wrote Goa, is actually working on a version 2, and right now you'll notice that the DSL is kind of very REST based, and the version 2 of this is going to be a lot more decoupled so that gRPC, WebSockets, and other protocols will potentially play a lot nicer with Goa in the future. So let's look at code generation. So I'm going to go ahead and put this mic down for a second. All right, so we're in the Goa seller location. Before I generate using the make file, I'm actually going to comment out one thing, which is the GORMA declaration. Prior to this demo tonight, I actually tried to get GORMA working, and unfortunately, I could not get it to do what I wanted to do for demo purposes. So I'm going to comment that out. In here, I can essentially call make generate. And that's going to essentially walk through all these different Goa gen commands. You can see here that we are generating our app, we're generating our Swagger file, generating our CLI tool, our CLI tool, our client, and even a JavaScript client. Oh, sorry, are we getting cut off here? Okay. But when we run make generate, we essentially get all that for free. And as you can see, it's actually very quick. We have some APIs that have probably close to 100 endpoints for various things at Engaged, and even then generation is only about 2 or 3 seconds for all those endpoints. So speed is really a non-issue with Goa from a generation standpoint. So now that we have these APIs, how do we actually run them, right? So let's go ahead and build these APIs, or build this, this package. And I'm just going to go ahead and Goa seller this locally. One of the things we've done in this example is it's actually not using a real database. It's more of kind of a mock data store. When we initially run Goa, if we've implemented a logger, you'll see that when you run it, all the endpoints which are available to you will get essentially spit out within the terminal, or the standard out. And so basically, post, delete, the full CRUD for accounts, the full CRUD for bottles is essentially, kind of listed here in our terminal. Now we have that. That's great. How do we actually hit it? How do we use it? So what I'm going to go ahead and show you right now, I've created a PAW file, which actually kind of messes around with this API. Yes? Yep. That's very good point, Chris. So you can actually import the Swagger file into PAW. One thing I've started doing that, but I've kind of got away from it, and maybe there's a way to figure this out. But in PAW, I like to parameterize my API. So in this case, we have an environment host variable. For production, it's hitting production server. But if I just want to hit our local API, it hits our local API. So since we can parameterize our request, it makes that easy to essentially use one API definition for different environments. So from an endpoint standpoint, we have list accounts. So go ahead and hit that. You'll see I get back 2 items. We have an account 1 and account 2. There's really not a whole lot to each of these. From an API standpoint, this is actually returning a smaller view for account. If I actually fetch a specific account, okay, I stand corrected. It's the same view. An account has bottles associated with it, which are bottles of wine. If I go ahead and run that, same thing, I will essentially get all the bottles of wine associated with an account. You can see the bottle of wine has an href associated with it, has an ID, it has a name, a rating. If I want to actually create my own bottle, I can specify some parameters here within JSON. And from a validation standpoint, just to kind of validate that Go is working as expected, these are all the parameters that are required. But let's say I omit name and I go ahead and try to execute that. We actually get a response back from Goa saying, hey, this is a bad request. What was the reason it was bad? Attribute name of raw is missing and required. So not only does it give you validation from an error response standpoint, it will actually give enough information, hopefully, for the user to kind of figure out what they did wrong. And that's another super valuable feature of Go. So let me go ahead and add that back to the payload. If I run that again, we created that. From a response standpoint, you'll notice that we're not actually returning the object. So kind of as a quick coding demonstration, let's go ahead and go back to our design file. That was for a bottle. So we're going to look at our resources. We're going to go to a bottle, which is create. And then what we want to do here is we want to return the bottle media type in the response. So let's go ahead and do that. So what I've done here is I specified that the created can also return a bottle response. I'm going to go ahead and kill this API. I'm going to go ahead and regenerate. And now I'm going to go to my controller, which actually has the bottle implementation. And you'll notice I have context created here, which is great. I want to return the bottle as part of the response. I can just reference the bottle. Save that. I really need to buy Sublime Text. And let's go ahead and go build. And aha, that's right. Our bottle is actually our model object. So we need to convert this to our actual Goa expected media type. And I believe I have some conversion functions here to bottle media. Let's try that. All right. We don't have an account model here. So in lieu of that, I'm going to create another function here. Find account. There we go. So now I'm going to take that bottle media. It's a little bit cheating here because it's not returning all the fields. But now if I go build this and then remount it, rerun it, do this, run this API again, you'll see here I actually get back the, kind of what I expected, more or less. A little bit less because we're taking some shortcuts here. So that's kind of a demonstration of Goa locally. Another tool I want to show you, which we also leverage here at Engaged, and this will be quick because I know we're running a little over time, is a tool called Convox. Convox is essentially a Heroku-like abstraction for AWS. Convox is built on top of Elastic Container Services in that it uses Docker to deploy to Elastic Container Services. You essentially Dockerize your application, which is good for both local development and deployment to Convox. In Convox, they have this concept of a rack. A rack is essentially an environment where your applications are hosted. And in AWS terms, it's actually its own private VPC. In addition to that, you also have abstraction for common AWS services like RDS, Redis, Memcached, SNS, which you can link to. Since we don't have a database, it doesn't really matter. But for deploying through Convox, Convox is essentially a CLI tool. So I have a service here locally which I'm running, and I can essentially start up the local development with Docker using a Docker file which I've previously defined. And I'm going to specify the app is called seller, or actually, I'm going to specify the file. It's equal local. So since it's based off of Docker, when you are running Convox locally and deploying remotely, you essentially need a Docker compose file. I have two Docker Compose files here. I have a local development, Docker Compose for local development, and then another file for production deployment. And we'll look at what those actually do. So that's going to go ahead and essentially run our. It's going to number one. It's going to compile all our Go code, and then it's going to run it in a Docker container. That takes a little bit of time. One of the ways we can optimize this is essentially compile the code outside the container and then copy in the binary. But for expedience sake for this demo, I decided not to do that. What you can see here is that we also have our Docker container running. We also have a database container running, which I initially was going to use when we had a database backend with Gorma, which I ended up not using due to time constraints. But now, if I go back here and I hit our local API, I should be able to hit it just fine within the Docker container. Now, if I want to actually deploy this Docker container up to AWS with Convox, I can essentially just do Convox deploy. And Convox actually has a convenience function in that it will use the folder name as your app name. In this case, the folder name is Goa Seller and the app name is Seller, so I have to specify it. Again, I'm a big fan of explicit over implicit, so I usually specify it every time. And then, since the deployment can take a couple minutes, I add a -- wait, which will kind of keep the thing blocked until it's finished deploying. So what it's doing now is essentially uploading the container to AWS's an AWS instance. It will essentially build that container on AWS and then register it with a private, I believe, ECR container registry. And then from that registry, it will deploy that container out to Elastic Container Service. This process it's going to take some time, so we don't actually have to finish and wait for it to deploy. I did deploy it earlier, figuring the Wi-Fi here might be a little slow. So I'm going to switch my environment from local to production. You can see we have this kind of seller main URL. To actually see where I get that from, I can do Convox. I have apps and I have info, so we have a bunch of apps associated with this account. On this rack, I really only have the seller application. If I want to get a specific application, I can just specify the app. And to do that, it'll tell me the status of the app, what process is running, and then the endpoint, which is the endpoint we're using in our PAW file. So now if I hit this, this is actually hitting the remote API. You can see it takes a little bit longer, 175 milliseconds versus milliseconds. And this is essentially hitting the Docker container in the cloud. So that's kind of a very Cliff Notes version of what Convox is and how it would work. From a container standpoint, what a Docker file looks like. Docker file is actually very simple. This one actually is using the Golang image. We're using the Alpine image, which is a little bit smaller. We're exposing a port. We're setting our working directory, and then we're copying our code, and then using some convenience methods within the container to essentially install that. From here, we have a Docker Compose file where we have some information in here. The main is what you saw in the URL. We're basically telling to build, and we're exposing port 80 to the world, and that internally is getting routed to port 8081, and then the entry point is Goa Seller. So that's kind of the Cliff Notes version of Docker. From a resource standpoint, or from a Convox command standpoint, here are some kind of common Convox commands. Deploying to AWS, getting information from an app, running local development, and then listing services. We've had a very positive experience with Convox. If you are interested in using Docker and interested in deploying to AWS and kind of not having to worry about a lot of the abstractions or poor abstractions that AWS offers, I do highly recommend taking a look at it. It will definitely make your life easier. It's very scriptable and can kind of be incorporated into any kind of continuous integration environment. Extending Goa. So we touched on that briefly. I'm not going to touch on it more unless we can potentially touch on it in Q&A. But for further reading, if you're interested in Goa, I highly recommend looking at goa.design. The GitHub organization is fantastic from a documentation standpoint. As Chris mentioned, there's an examples repo, there's Goa Seller, there's Gorma Seller. That's a great place to kind of get your feet wet to see what the DSL can do and how you can potentially leverage it in your apps. From a Slack standpoint or a community standpoint, highly recommend joining the Goa channel in the Golang Bridge Slack. Raphael Simone, the creator of Goa, is very active in there. Chances he will answer any questions you might have, and there are a lot of other enthusiasts in there who will be happy to answer your questions and make plans on Goa world domination. So that's pretty much it. Appreciate you guys coming out, and if there's any questions, now's a great time.
Could I ask the people asking questions to use this microphone, please?
So one of the things we were looking at where I work is, we're getting into Go, and we're definitely into like Swagger and having a machine readable definition of your API. And one of the conversations that we've been having back and forth is, okay, do you start with the code and document there and use the comments and generate Swagger from that?
Yep.
Do you start with a Swagger file and have a way to validate that your code actually does what the Swagger does?
Mm-hmm.
This is a different approach where you have a DSL. You start with DSL and you generate both the code and the Swagger.
Yep.
And it's like you can do any of those from any direction. And I'm wondering if because I was reading the DSL and I was like, that looks almost exactly like Swagger, right?
Yeah.
There's like
Yeah.
or RAML or whatever it seems like roughly equivalently expressive.
Yep.
Is there benefits to starting with the DSL first?
I think so. I mean, if you can get buy-in from the rest of your organization to start with the DSL, it's definitely a great starting point. How we use it at Engaged is when we're building a new API, what we'll do is we'll define the DSL for that API, and then we'll generate the Swagger file from that DSL. So without actually writing the business logic implementation, then we'll take that Swagger file, which is a little bit more user-friendly, and then meet with the stakeholders who are going to be hitting that API, whether it's front-end, mobile, contractors, and just kind of have an API review from that Swagger file. Based on that, we'll usually get feedback on how we want to tweak the design. We'll go ahead and make the appropriate DSL changes and then bubble up another Swagger file. Once everybody gets buy-in from that, then we essentially move forward with the actual implementation of said API. Does that answer your question, or kind of? Okay.
So that is okay. So that explains the workflow model, right?
Yep.
So it's like where you go to generate once, basically, or only on an additive basis, because you're not iterating in code on the design in terms of implementation. You've already done your iteration up front on the API design, and so you're just kind of like unidirectional. And I think that the people who are in our org who are advocating for generating it from the code is because they expect to be able to modify that code and then generate the Swagger, and they still want it to be accurate. So that explains why the workflow is the way it is. So it's like it's just optimized for a different workflow. It
Fair.
makes sense. So I get it now. Thanks.
Cool.
So is it currently, can I go from code, if I already have an API already developed, can I go to?
Unfortunately not. It is one way, and there have been lots of, you probably see a request or two a week in the Goa channel or from other people, can I take my existing Swagger file and generate a Goa DSL from that? Right now, no. I think that would be a great plugin or open source contribution though.
Cool, thanks.
Do you check in your generated code?
Great question. Yes, in fact, we've had some lessons learned, best practices. Definitely check in your generated code. If you think of what you're checking in as kind of an atomic unit of work, which you can eventually build and deploy from, then it definitely makes sense to check it in. There may be other opinions on that, but that's what we do at Engaged.
What would be the downside of not? Because it seems like because it should be repeatable.
It should be repeatable if assuming you vendor your dependency, so you're vendoring the version of code, Goa, that you are using to generate that, then in theory, you probably can get away from that. But if you're not vendoring your dependencies, then you don't know what version of Goa is going to try, generate that code. And if it's an incompatible version or something broke, then that's always the concern.
So have you found any downsides to checking it in? The worst case scenario is that someone forgets to generate.
I think the worst case, yeah, the worst case scenario is someone fails to generate, and then if you're changing a lot of stuff, then you're going to have in your pull request, right, your change files and modify lines of code, it's actually going to get real busy versus, you know, the actual business logic that changed. So that,
better than a framework in a sense, but because it, the way we see it is it relies on Goa, it's like framework in a way, like Rails or Django or whatever, but it's a little more, it's less magical.
yeah, that's a great way of saying it. It's a compile time framework. That's exactly what it is. Yeah.
If I get a pull request in, though, if I get a pull request in to the code that's generated, right, now I have to go back to Goa, the Goa code, right?
Well,
and,
you're gonna if someone's pull requesting a generated code, that's almost like a process problem, right? Because ideally, no one's pull requesting the generated code like from I guess a manual implementation, but from like a generated implementation, then yeah, you're gonna have to, I guess, review that, right? You don't have a choice.
add it to the.
Yeah. I mean, a pull request can totally have generated code in it, right? Because if I add different media types and different endpoints,
They don't understand the project well enough to know that they shouldn't have done that.
Yep.
yeah. From a generated code standpoint, Goa, when you have an app folder which has, you know, the primary generated, you know, Goa code in it, you also have other folders. Goa will wipe that folder out when you regenerate. Gorma is a little bit more forgiving in that it will not wipe out the files you create, which is both good and bad. In an ideal world, you never touch any generated code or any generated package. That I think is the ideal.
Cool.
One of the things I struggled with was I had trouble finding an example client. Super basic,
Yeah.
but I just couldn't find one. Now I knew that the CLI actually uses the client,
Mm-hmm.
but it's complex enough where I had trouble making heads or tails.
Yeah, I think the first time when you're first coming into Goa and, you know, understanding all the interdependencies, you know, to your point, the CLI depends on the client. It is a little bit intimidating at first. There's definitely room for improvement kind of in the documenting the process and the interdependencies. But once you get past that, I mean, you know, it's for us, it was like kind of like a light bulb. You know, it's just, you know, the value prop is just so high. We've been able to, you know, create, you know, many different APIs with a very small, you know, team. It's what Go is basically a multiplier for that.
Do you guys use the client much?
Right now, no. The closest we would get to that is we're sharing models between our different APIs.
The client's quite nice.
Cool. Any other questions?
Do you feel that Goa is ever overkill, like for, you know, a very bare API, or would you use it pretty much no matter what?
That's a great question. I think, you know, going down the right tool for the right job, there's a place for Goa and there's a place not for Goa. I'm not really sure where I would draw that line because we have some very simple APIs that work like auth, which are like, you know, 2 endpoints, and we still use Goa for it. For us, I mean, we're using Goa pretty much everywhere from a convention standpoint. I could totally see there being a reason not to use it. I just don't know what that reason is right now. Cool. Any other questions? All right. Thanks, everybody. Don't forget your stickers.
Yeah, so everybody, thanks for coming out. Obviously, thank you to our hosts, Humble, who provide the pizza and the beer and the really wonderful space and all the AV equipment. Next month, in November, we're going to have Judd White coming to talk a little bit about GoFuzz, which is a really fun library you can do a lot of different things with, whether using it in testing or security or what. And we're going to play around with a little network parser that he's built with it. And so, yeah, it should be fun. And if you're not in the Slack channel, since apparently Slack is, for the moment, Slack is beating IRC. I don't think IRC will ever really die. It'll be the domain of geeks and perverts till the end of time. But right now, it seems that the place to do your Go business is in the Slack channel. So definitely, if you're not already in there, join Go for Slack and come on into the ATX channel. I wish it was too. Yeah, there's only like 2 or 3 of us talk on a regular basis, but we could chatter more. Yeah, I didn't think you were busy enough.
Also, thanks to our at-home viewers. I think there was like 4 to 6 throughout the night. So definitely, we're all for like getting any feedback on the quality of the audio and the video. I've been back in the sound booth, manning that for the rest through the night. But yeah. Yeah, these are like some really bright lights. But yeah, and also thanks for talking on the microphones and making that work. So hopefully that'll be a regular thing and develop an archive of talks. And also, I'll reach out to the North Meetup as well and see if they can, post to their members as well, so we can try to get these more, spread out. So, and as always, we're always looking for speakers for future meetups. So if anybody has any thoughts on talk or any content for upcoming, I don't know if we're going to do anything in December necessarily.
Some kind of party, right? Like, we'll take it around. Like, we'll either do our
Talked a little bit.
party. Yeah, sorry. So December, we'll either do our own little meetup party kind of thing like we've done before, or sometimes there's some other sort of pan meetup holiday parties you can piggyback on. So still kind of looking into that. But yeah, I think the next actual meetup proper after November will be January in terms of us looking to fill a speaker slot. So if that's you, give me a shout on the Slack.
Also, I believe somebody had mentioned the idea of doing a lightning talk on the meetup page. Is that still a thing? We still have, I think, some time, so we could definitely accommodate some short talks. If not, then we'll, I guess, just open it up to socializing, hanging out. We have a little bit of beer left, no pizza, but y'all are welcome to hang out for a little bit. So, all right. Thanks, everybody.